I'm Jim Cotton, and I'm excited to be making a presentation to you today on a very interesting topic, which is the sustainability of tonewoods. Now, you might be asking yourself, what are tonewoods? And this is a very simple definition. Tonewoods are the woods that are used to construct musical instruments. And the dominant tonewood species are spruce, rosewood, mahogany, and ebony. The use of these species for these applications has been matured and developed for the last few centuries, and they've truly become established as the benchmark species to make a great sounding instrument. And in fact, those instruments sound so great that in the last few decades, the acoustic guitar has become the most popular musical instrument in the world. In fact, if you look at the numbers, there are over 2.5 million guitars sold every year in the United States alone. And it requires a lot of resources. So you might be asking, where do those resources come from? Well, let's take a look at that. If you take a look at the world map and where the United States guitar production began, which was really in Pennsylvania, under the auspices of Christian Martin, who basically set the benchmark designs for modern acoustics. He used Adirondack spruce, which was a local species, fairly easy to get. And that was done for a long time until it became difficult to get, in part because that type of spruce was also used for other applications like furniture and transportation, and even in the war effort. It became so hard to get that eventually spruce was shifted from Adirondack to Sitka spruce in the Pacific Northwest. And a lot of this came from old growth spruce, very large trees that were very efficient to produce guitar tops from. And if you look at the numbers now, about 80% of modern solid wood guitars actually have Sitka spruce tops. Unfortunately, most of that old growth has been cut. When it comes to necks, Honduran mahogany is the material of choice, and that originates from Central America. And sadly, about 70% of those native forests have also been cut, and cut so extensively that that species has merited special international protection under the CITES and IUCN regulations. As far as the backs and sides, Brazilian rosewood has been the standard for a long, long time. And sadly, again, about 90% of those forests have been cut. And in fact, Brazilian rosewood was the very first wood that was placed under international protection under CITES legislation. Since those have largely been exhausted, there was a shift to another rosewood species, which comes out of East India, and now that's being very aggressively harvested. And likewise, it has picked up international protection, and that makes it more difficult to obtain, even though it is the dominant instrument grade rosewood, but it's in trouble. And then finally, when it comes to the fretboards, ebony is the traditional tone wood, and ebony comes from a variety of species, but the main one is from equatorial Africa, and primarily these days just from Cameroon. Because most of those forests have also been over-harvested, it also has protections in place. So I think we have a problem here. Tonewoods have a sustainability problem. And even though you can go out and buy a very nice guitar now made from these woods, that can't continue. And there are other possibilities that are being explored. But the real question we want to ask ourselves is, are these species really necessary? Do we have to have rosewood to build a great sounding guitar? And do we have to have Sitka spruce to build a great sounding guitar? So that's what we wanted to examine in this study. And I felt that the Ansys Granta Selector tool was ideal because it actually has about 500 wood species built into the database, and it seemed to lend itself to this problem. And I finally had the chance to do this study working with John over the last several months. So let's dive in. Anytime you want to do a material selection problem, you have to look at what are the design drivers. In other words, what properties actually dictate how well that component will perform in service. In this case, we're looking at an acoustic guitar, and not all components are shown here, but the largest ones are shown here. So you have the soundboard, which is the top or the light colored wood, the body, which collectively means the back and sides, the bridge, which is smaller but still a very important component because it transfers the acoustic energy from the strings into the top. You have the fretboard and you have the neck. In the interest of time, I'm only going to look at two of these today, which is the soundboard and the body. Now, when it comes to the soundboard, or the top, one of the most important properties, obviously, is loudness. I mean, you want the soundboard to radiate the acoustic energy and represent all the frequencies that are generated within the instrument. And that's also called the timbre. How do you measure that? In fact, how do you estimate what that might be a priori? In other words, before you actually build a guitar out of a particular kind of wood and into a particular design? Well, some folks have looked at this problem, and there are a few papers published, and they've identified a variety of parameters, and one of the best ones is called the Acoustic Conversion Efficiency, or ACE. And that's shown by this, that can be estimated by this expression here, which involves the Young's modulus, the density, and the damping coefficient. And I'll just say here, any properties that have a directionality are always represented in the analyses in this presentation in the longitudinal direction. I mean, wood is an anisotropic material, and a lot of the performance is dictated by the longitudinal properties, the direction of the cellulose fibers. So if you can take this expression and actually put it into the Granta database and have it generate the ACE values for all of the wood species and then compare them. So that was the next step. And if you do that, you can stack them up from highest to lowest with each species represented by one vertical line, which shows the high and low ends of the calculated ACE values. The higher you are on this graph, the louder you would expect the instrument to be, and vice versa. So it goes from high on the upper left to low on the lower right. And if you do a simple box selection within the Granta tool, you can identify the top performing species, and that gets us from about 500 down to 47 species to evaluate further. And you can see right away that most of these are actually spruce. At least the important spruce species when it comes to instrument building are reflected there. The next important property is the compressive strength, because the fully tensioned up instrument has about 200 pounds of load typically placed on that soundboard. But the tool makes it quite easy, and it looks like that all of the 47 species that were selected based on conversion efficiency also meet or exceed the strength of Sitka spruce. So we can move on. Now we can move out of the Granta tool and into some of these other factors. And the first one is tree form. If you're going to build a guitar and you're going to make tops for a guitar the conventional way, the tree's got to be big enough and straight enough to practically extract those tops. And so some rules were set up here to do that and eliminate trees that wouldn't work very well. So the basic rules are it should be at least 2 feet in diameter at maturity, and it should grow pretty straight. So you can see an example here where the yew tree on the left would not work very well, and the Douglas fir on the right would work pretty well. That gets us down to about 29 species. Okay, the next factor is sustainability. And in this case, we took a fairly simplistic approach, which was to say it can't be on a list. If there's a list that points to any species being in trouble in any particular way, it was just simply removed from consideration. Even if it was a, only, maybe least threatened condition or there's simple concerns about it. If it's on a list, then it was removed from consideration just to avoid the debate. And then another sustainability factor is the growth rate should be at least moderate to fast, because very slow growing species are probably not going to work in the long run because they can't replace themselves in time. And then finally, producibility. Any species that is difficult to bend, form, machine, finish is going to be expensive and consume more resources in the manufacture of instruments. So these producibility factors are available in online databases, and those were very helpful in getting us down to a short list of about 15 species. So this process, the process flow is shown here, starting from about 498 species and getting us down to 15, and those 15 are listed here. And what you'll notice out of them is that they're basically all soft woods, and they're really just about all conifers. So we have a good mix of fir, spruce, and pine, and one poplar tree here. You'll also notice that most of these are North American species. Okay, so now we can move on to bodywoods and do a similar type of analysis. In contrast to the top, the body is there mostly to reflect, maybe to absorb a bit of vibration and re-radiate that and thereby color the timbre of the instrument. But for the most part, it's reflecting sound internally. And the great thing is that we have these established benchmarks of rosewood and mahogany. So if we calculate the ACE values for those two benchmark species, we can look at all the species in between, and ostensibly those should sound just about as good. Secondly, we added another parameter here called the sensitivity to pressure difference, or SPD, as a performance index. The reason this was chosen is that the guitar in some ways is actually like a pressure actuator. I mean, you're inputting a signal and the guitar is resonating and generating a signal back out. To do that in the most sensitive way, you would like to activate these low frequency modes where the guitar is almost breathing, and that makes it look an awful lot like a pressure actuator. So by adopting that particular index, it helps us distinguish between guitars that should help promote these lower frequencies and those that don't. It's a very simple expression. It's the yield strength to the 1.5 power divided by the modulus. And again, those properties are built into Granta. Okay, but let's look at ACE first. Same kind of stack up as before. Louder's towards the top. But instead of placing the box at the very top, like we did for the soundboard, where we want to radiate as much as possible, we have bracketed mahogany and rosewood. And so that left about 196 species passing. Now we move on to the SPD performance index and do the same thing, rosewood to mahogany. That took out about another 10 species. The next stage is the characteristic impedance, and this is the acoustic impedance, which is a measure of how easily acoustic energy is transferred from one medium to another one. Once more, we would like these woods to look a lot like the established benchmarks of rosewood and mahogany, so same thing. Draw a box which is bounded by those two species, and you get everything in between. This gets us down to 123 species. The fourth one looks at compressive strength, and even though strength isn't a major driver for the backs and sides, it does carry some load, some transferred load from the internal bracing structure, so it matters. Same approach, bounded by rosewood and mahogany, and we get down to about 113. And then finally, because that was an awful large number of bodywoods, I looked for another parameter that would be helpful, and there are estimates for the amount of shrinkage that takes place on drying. You would like to minimize this shrinkage because if the shrinkage is excessive, then you can get a lot of distortion, and that can make it difficult to build an instrument. So same thing, box selection that just catches the lower edges of the ranges for rosewood and mahogany, And that gets us down to 72 passing. And looking back, this was a little arbitrary. I probably could have left it out, or I could have made the box bigger, but I felt like there were some great selections that were going to occur, and I left it. So this is a summary of that process flow for the body woods and how we went from 498 down to only 14, and those 14 are shown here. And you'll see an interesting mix of what are, again, mostly conifers. You have cedar, fir, hemlock, and so on. There are some other interesting species that are probably not in use for tonewoods, but would be interesting to analyze. So we have two short lists now, one for the tops and one for the backs and sides. The next question is, has anyone done this? Are there any guitars out there that actually meet these criteria and you could call them more sustainable? There's a few, not many. There's actually a Canadian manufacturer called Godin that has a number of different guitar lines. One of them is the Coastline series, and these guitars use red cedar for the tops, black cherry for the backs and sides, and silver maple for the necks, which is interesting. And they have another line called La Patrie, which produces classical guitars. And I actually have one of these models, an older one from the early 2000s. And back then they were making the bodies out of mahogany, and around 2008 they switched to black cherry. And sometime after that, my son bought the same model, basically the same in every way, except for these body woods. Now they did it to reduce cost, but it also meets the criterion for improved sustainability. And I thought it would be interesting to play for you just a few chords on both guitars, recorded in exactly the same way, and let you hear for yourselves whether they sound similar. So here's the older one, which has the mahogany in it. Okay, sounds very nice. Now compare that to the black cherry. Different, but still nice. It's a little warmer on the finger style, and then almost a little brighter when I got the nail on there. So I don't know. I mean, every wood's going to be different. It's going to have a different character, but I think they both sounded good. And I kind of thought from the get-go, when this study was completed, we could put everything in a matrix and then go out and identify all the makers out there who were producing guitar models that met the criteria. But it turns out there really aren't very many. I filled in a few, but I think you can see there's lots and lots and lots of room for experimentation and development into more sustainable models. So let's wrap it up. I think my first point is that the guitar is the most popular instrument in the world, and it consumes a lot of natural resources for manufacturing, and a lot of these are premium selections. The traditional wood species that are used for guitars are really not sustainable anymore. I mean, you can still get them, they're still out there, but it's not good for the environment and it can't continue. And the most interesting thing is that it's probably not even necessary, because in this study we looked at almost 500 tree species and we ran the trade studies for how well all of those species would work in terms of acoustic, mechanical properties, tree form, producibility, and sustainability to build musical instruments. And in that process, dozens of more sustainable tonewood species were identified. By exploring these alternatives, we could remove pressure from traditional and tropical species, because many of them are tropical and coming from rainforests, and we could create more interesting and diverse offerings in instrument design. And I would think guitar manufacturers would want to do that. It could distinguish them from some of their competition and probably lower their costs, because they could start looking at locally available resources that are more renewable. So if you want to buy a guitar sometime in the near future, I hope you'll think about that and you'll actually look at the tonewoods that are in it and try to choose those that are sustainable. I'd like to acknowledge a couple folks who were very helpful in putting this study together. One is David Saban, who's a professor at the University of Cambridge. David helped me get access to the Granta Selector for the term of this study, and I appreciate that very much. And also to Steve McMinn, who was kind enough to answer so many of my questions up at Pacific Rim Tonewoods, which is north of here a couple hours in the state of Washington. So with that, I thank you for your kind attention, and if you have any questions of your own, feel free to email me. My email address is there on the lower left, and I wish you all the best. Thank you.